My presentation is face-selective neurons in the vicinity of the human fusiform face area. This is a one-patient case study. Here you see the number of this patient, and she was recorded in May-June 2017. And this project was together with Camille, Tal, and obviously Lionel. Okay, first let's start what is face-selective neurons. They have been discovered in the late 16th, early 70s by Charles Gross. So those are the neurons that respond more selectively to faces than to other categories. They were discovered in monkeys, and this is an example from monkey study in the inferior temporal cortex. You can see there is much higher firing range for face stimuli. In humans, face selective activity has been explored extensively, especially using fMRI and electrophysiology. And the largest region with face selective activity is the fusiform face area. It was first shown using positron emission tomography by Sergent, and then it was named by Nancy Canvisher in 1997. It was also explored using intracranial recordings, but most interesting part is that the neurons were never shown in this region. And this is what was our project about. So we had one patient, rare patient, with the electrode implanted with the tip of the electrode. The microwires were close to the fusiform face area. Actually, it's not fusiform area, it was in the posterior fusiform gyrus, and we conducted fMRI recording, fMRI scanning after the electrodes were already extracted, several months after that. And what I show you here are the activation of this specific patient, and what you see is a green circle is the approximate location of the microwires. We obviously cannot know exactly because it is co-registration between MRI and fMRI and electrodes, and we are not sure whether we see them on the CT. So we indicated as approximate location, which was either within the FFA or near the FFA. Okay. And so we identified 4 multi-units from our contacts for multi-unit activities, so that they can be analyzed. And the analysis was conducted using wave class toolbox in MATLAB. So here are the experiment 1. We showed pictures of famous and non-famous, familiar and unfamiliar faces, familiar and unfamiliar scenes, and objects. All the faces were famous people, like some of them were Frenchmen, French women that were familiar for the patient, and some were mostly Israeli faces, so they were not familiar to the patient. And in the scene, the same idea. And objects, it's just objects. And here are the results. This is called raster plot. X-axis is the time, y-axis is the trials, and they are separated to the conditions. And each small pixel, small dot, is a spike of the neuron. And what you can see here is that for 2 conditions of faces, there were bursts of activity starting about 150 milliseconds. There were also some activity for objects, but keep in mind that we are talking about multi-unit and not single unit, so it is possible that there were several neurons actually that we recorded, so we cannot say whether the face selective, whether it was a single face neuron that responded both to faces and objects. But most important is that we have very clear and sharp face selective activity in this multi-unit. Here is another way to see the results. And on the left side it is the same raster plot, and on the right side you see the across trials mean instantaneous firing rate. So it is average across trials. Obviously, only one patient, only one subject. And what you see here is that from about 10-20 spikes per second, the firing rate increased to up to almost 80 spikes per second. So obviously the exact number of spikes it depends how you set your threshold in the wave class, but in general this is the magnitude of the increase. So it increased threefold increase compared to 1% signal change in fMRI. In best case, it is very spectacular. And you can see also, as I showed you, the yellow one is the object activity. And here what I did in addition, each phase, each identity of phase, for example, Nicolas Sarkozy, was represented by several images. So I could check whether we have selectivity for a specific identity, like if you remember the paper with Jennifer Aniston, neuron in hippocampus. So, but what strikingly what we see here is that the neurons responded to all phases, to most images, so there was no selectivity for specific identity. This is in contrast to hippocampus. So the increase was not specific per identity, but for phases in general. Here is I told you that there were 4 units. Here is additional phase selective units that we found, and it was also phase selective, this time even without object selectivity, the same idea. And 2 additional units were completely not phase selective. Here one of them, its response was even a bit stronger for scenes. You see the blue trace, it is unfamiliar scenes. And the last unit was just sort of noisy without any interesting results. But it happens, and the fact that we out of 4 units that we recorded, 2 of them were phase selective. It is still very, very surprising that we were able to find such neurons. And experiment 2, we wanted to see whether we can find phase selective activity also within a movie with more natural stimuli. So it was 6 minutes from a silent movie of Charlie Chaplin, the circus movie. It was silent but with music on the background. And here I show you just several examples of phase selectivity that we found. For example, this is a segment of 8 seconds, and the trace is a firing rate, and the pictures, the frames, are representative frames of this period of time, of these 2 seconds. And you can see that for phase there was increase in firing rate. The increase is less strong than for static phases, because there were a lot of pictures, a lot of moving frames, and a lot of faces in the movie. Examples that I like even more is here. You can see that there are small faces, but once appear a face of a donkey, there was much stronger increase in firing rate. In fact, it was one of the strongest increases within the whole movie. This is a single signal segment analysis, but we want to see the average make statistics. So what I did, I took the movie and bin into the segments of 200 milliseconds, so that we have 1,800 segments of 200 milliseconds, and then I calculated average firing rate within each segment. This is the way we can make a statistics afterwards. And here what I get. So if we bin the frames of the movie to the frames with a large phase, medium phase, small phase, and no phase, you see that there are very few, relatively few no phase, because it's a movie of Charlie Chaplin, the faces appear all the time. So what you see here is that each blue small dot, small pixel, is activity within single frame. So and the red one is the average, and you can see that on average the firing rate was much stronger for large phases than medium phases and smaller phases. Briefly, the higher firing rate for larger face. As I said before, the Z-score you can see relatively small because it's the movie faces all the the frames also consecutive one after another, so you cannot expect the same magnitude of effect like with static stimuli. And here example of the unit 2. Again, it was a bit more stronger for faces than for non-faces, but the effect was much smaller than in first unit, but still it was significantly less stronger for large faces than for no face. And interestingly, in this unit 3 with the opposite selectivity, you can see that the activity was higher for non-face than for faces. So it was the opposite selectivity, and here is a fourth unit that again was stronger activity for no face. Okay, this is all that I wanted to tell you. Now you will see the demonstration of several single stimuli in the experiment 1. You will see it will be sort of real time. It's the speed of the presentation. So if the trial is one second, it will take 1 second, and you will see it will be the spike rate. You will hear it as we usually hear, and then you will see the example of the donkey that I showed you. But you will see how this progress. And thank you.